everyone, this is the second part video about model evaluation in machine learning. Well, let's begin. Regression. The regression learners predict continuous values, and the metrics find how close a predicted value is to the real value, the ground truth value, by difference, represented by y minus y predicted. Some popular metric functions for regressions are R**score is a number that indicates the proportion of variance in the predicted output from the real output. It is calculated as follows. In this formula, you can see R**score is defined by 1 minus the summatory of each value in the dataset. This value is subtracted by predicted value at square and summatory of each real value minus average of real values. In this formula, the close R** is to 1 better. Mean square error MSE measures the average of the squares of the errors of the predicted and the real value. Well, MSE formula, subtract the real value, the predicted value from a real value and at score. And in this formula, the closer MSE is to 0, the better. Root mean square error, RMSE, is a measure of the difference between values, sample and population values, predicted by a model or an estimator, and the truth ground values. RMSE is the square root of the value calculated by MSE. As you can see, MSE is MSE square root. The close RMSE is to 0, the better. Mean absolute error MAAE is similar to MSE, but it does not square error. You can see in this formula we don't have a square how we have on MSE, that this difference is at square. In this formula, difference is not at square. Mean absolute percent error MAP is another metric to evaluate regression model, and the errors is expressed in percentage. This is other metric, but has represented in percentage. And P and may are less sensitive to the occasionally very large error because they do not square the errors. If we want to ignore big prediction errors, P and may be used. However, RMSE is most recommended for these cases.